Okay, this is Chapter 5, Gas Welding, out of the Welding Practices and Principles book. Okay. We're going to start off with oxyacetylene welding here. Okay, oxyacetylene welding is a way to join metal by heating the surfaces to be joined to the melting point with a gas flame. Okay, fusing the molten metal into a homogeneous mass and then letting it cool into a single unit. Okay, this is done with a flame creating temperatures of somewhere between 5,800 and 6,300 degrees Fahrenheit. Okay, it's always been a common practice. Became a major welding process back years ago for fabrication and repair of worn tools and parts and things like that. It's getting a little more obsolete now, but it's still used extensively in different places for different reasons. Okay. Okay, let's start out with the gases that are used. Okay, the oxyacetylene welding process makes use of two principal gases, oxygen and acetylene. Okay. A number of other fuel gases are available for this. They are propylene, natural gas, propane, and a gas called MAP. Okay, and that's an actual trade name for it. But acetylene is the hottest of all of them. Okay. Oxygen is a gaseous chemical element in the air that's necessary for life. It's also the most abundant chemical element in the crust of the earth. Okay, has no color, no odor, no taste, does not burn, but by combining with other elements, it supports their combustion. Okay, there are two commercial processes used in the production of oxygen. One of these is the separation of air into oxygen and nitrogen by liquefying the air. Okay, the other method is the separation of water into oxygen and hydrogen by electrolysis of water. Okay, in other words, by passing it an electric current through it. Okay, by far the greatest part of the oxygen used commercially today is manufactured in the liquefaction process. Okay, steel cylinders are made from a single plate of high-grade steel that has been heat treated to develop maximum strength and hardness. All right. Cylinders undergo rigid testing and inspection. Oxygen is distributed in bulk tanks, and they're built basically to the same specifications. Each cylinder has a valve that must be opened to release the oxygen. Okay. Now on an oxygen valve, you need to open that cylinder all the way. Make sure it's fully open because it's got a backseating valve that has to open all the way. Okay. Otherwise, it'll allow leakage past it. Okay. The valve is protected from damage by an iron cap that screws onto the neck ring. Okay. Always make sure that cap is on. When the regulator's not on, anytime you're transporting the bottles, when they're not being used or a regulator's not on them, make sure they have the cap on them. Every cylinder valve has a safety device to blow off the oxygen long before there's any danger of explosion. Okay, there's a plug in the oxygen, top of the oxygen tank that'll pop out if it's over pressures or in the valve itself. There are three sizes of cylinders used for welding and cutting with oxygen. Gas suppliers fill their tanks with varying amounts of gas. Okay, the large size contains 220 to 244 cubic feet of oxygen. Weighs about 150 pounds when it's full. 130 to 133 pounds when it's empty. 110 to 122 cubic feet in the medium size weighs 79 to 93 pounds when it's empty. About 100 pounds when it's full. And the small size, 55 to 80 cubic feet, 67 pounds full, 60 pounds empty. All right, safety and handling. It is important to remember that pure oxygen under pressure is an active substance and will cause oily and greasy materials to burst into flames. So never use any oil or grease around any oxygen equipment, any regulators, any bottles, any hoses, or anything that will be in contact with the pure oxygen. When using the cylinders, Do not place them where oil might drop on them from overhead. Okay. Never use oxygen in pneumatic tools or to start internal combustion engines. Never use oxygen to blow out pipes or hoses, dust cloths, to create any kind of head pressure on a tank of any kind. Okay. Never use oxygen. Let's see. Do not store oxygen cylinders near an acetylene generator, carbide, acetylene, or other fuel gas cylinders. Always store them in a different area. Do not use the cylinder as a roller or lift by the cap. Keep the cylinders away from the welding operation and close to the cylinder valve when work is completed. Close the cylinder valve when the work is completed, I'm sorry. Keep the cylinders away from electrical contact. Don't be striking arcs on them or anything else. Okay, now let's talk about acetylene. Acetylene is the most widely used of all the fuel gases, both for welding and cutting. It is generated as a result of a chemical reaction that takes place when calcium carbide comes in contact with water. Laboratory tests have shown that oxyacetylene flame temperatures reach up to 6,300 degrees Fahrenheit. Okay? It has a very rapid rate of preheating. It gets hot in a hurry. That's why it's commonly used. Makes quick work out of preheating, welding, cutting, anything like that. Acetylene has a peculiar odor if lighted. It burns with a smoky flame, gives off a great deal of carbon and soot. You'll notice that when you first start lighting up the torch, you're going to see a lot of black smoke out of there. Commercial acetylene is made from calcium carbide, which is commonly referred to as carbide. Okay? It's a gray stone-like substance. We actually have some in the tool room in there. I'll show it to you one of these days. Mix it with water and put a spark lighter over the top and it flames right up. Like oxygen, acetylene is distributed in cylinders. The cylinders are constructed differently from oxygen cylinders because of the fact that free acetylene should not be stored at a pressure above 15 psi. Okay, these cylinders actually have a filler that's made of a real porous, like Portland cement inner piece that's in there that's really porous, and then the acetylene is absorbed into acetone that's also in there, and it goes into the pores of this stuff, and it can be safely stored that way. Okay, but it should never be stored over 15 psi or used over 15 psi. Okay. Acetylene valve. Acetylene is drawn off through the valve, and acetylene can only be drawn off at a certain rate from the bottle. Therefore, you only want to open the valve up 3/4 to 1.5 turns, okay, because that's all the faster that the acetylene can be drawn off anyway. And that way, if there's any kind of a problem or an explosion or anything like that, you can quickly get the valve shut off. Okay, the valves are a lot of times recessed down into the cylinders. Sometimes they're up on top. There's different kinds. One of them takes a particular kind of wrench to open and close, but most of the newer ones just have a regular knob, just like the oxygen cylinders have. Okay, a full cylinder of acetylene has a pressure of about 225 psi. Like I said, that can be safely stored at that high of pressure in the cylinder because of the porous concrete inside the cylinder and the acetone. Okay, the large size cylinder contains about 300 cubic feet of acetylene, weighs about 232 pounds when it's full. The smaller size contains 100 cubic feet and weighs about 91 pounds when it's full. Okay, not all the acetylene in the cylinder can be used. The maximum practical use of the gas is reached when the oxyacetylene flame begins to lengthen and loses much of its heat. And what will happen is if you keep trying to run it past that, you'll start sucking some of the acetone out into the equipment, the regulators and stuff like that. Okay, remember that acetylene will burn. Like any other combustible gas, it will form an explosive mixture with air. Okay, so use the following precautions. Do not leave acetylene cylinders on their sides. Always store them in the upright position and if the regulator's not on them, make sure the cap is. Okay. Store the cylinders in a well-protected, ventilated, dry location. They should not be near highly combustible materials such as oil or excelsior or stoves, radiators, furnaces, and other sources of heat. If the outlet valve becomes clogged with ice, thaw it out with warm water. Don't use an open flame or any kind of, fire or anything to thaw it out. Handle acetylene cylinders carefully. Rough handling, knocks, and falls can damage the cylinders and the valves or the fuse plugs and cause leakage. Acetylene cylinders also have a fuse plug so that if they overheat, temperature gets too high, they will vent off the gas rather than explode. If acetylene leaks around the valve spindle when the cylinder is open, close the spindle, move the cylinder to an outside area, and advise the supplier immediately. Never tamper with the fuse plug. Propane gas, another type of fuel gas that's used once in a while, okay? It's not as common, not as commonly used, mostly because it only achieves a temperature of about 5,190 degrees. Okay, that's a lot less than the 6,300 that acetylene will generate. Okay, then you have MAP gas, 5,300 degrees. Okay, so still 1,000 degrees cooler than the acetylene. General storage information and handling information, okay. All portable cylinders used for the storage and shipment of compressed gases shall be constructed and maintained in accordance with regulations of the U.S. Department of Transportation. Compressed gas cylinders shall be legibly marked for the purpose of identifying the gas content. Now remember that oxygen is always green, acetylene is always red. Compressed gas cylinders shall be equipped with connections complying to the American National Standard. Remember, oxygen always has right-hand threads, acetylene always has left-hand threads, and always has a groove cut in the flats of the nut. All cylinders with water weight capacity of over 30 pounds shall be equipped with a means of connecting the valve protection cap or with a collar or recess to protect the valve. Cylinders shall be kept away from the radiators and other sources of heat. Inside a building, cylinders shall be stored in a well-protected, well-ventilated, dry location at least 20 feet from highly combustible materials such as oil or excelsior. Cylinders should be stored in clearly identified, assigned places away from elevators, stairs, or gangways. Okay. Valves on empty cylinders shall be closed. For cylinders designed to accept a valve protection cap, the cap shall always be in place, hand tight, except when cylinders are in use or connected for use. For fuel gas cylinder storage inside a building, cylinders except those in actual use or attached, ready for use, shall be limited to a total gas capacity of 2,000 cubic feet or 300 pounds of liquefied petroleum gas. Oxygen cylinders shall not be stored near highly combustible material, okay. Oxygen cylinders in storage shall be separated from fuel gas cylinders or combustible materials. Cylinders, cylinder valves, couplings, regulators, hoses, and apparatus shall be kept free from oily or greasy substances. Okay, we talked about that before. Don't ever let any oil or grease get around anything that has to do with compressed gases. A cradle, boat, or suitable platform must be used when transporting cylinders by a crane or derrick. Cylinders shall not be dropped, roughly handled, or struck, or permitted to strike each other violently. Rough handling, knocks, or falls are liable to damage the cylinder or the valve. Valve protection caps shall not be used for lifting cylinders, okay? Unless cylinders are secured on a special truck, regulators shall be removed and valve protection caps, when provided for, shall be put in place before cylinders are moved. Always make sure the caps are on them if they're available. Some of the acetylene bottles, the valve is recessed down into the top, so it's protected from being knocked off and stuff by being down inside. Cylinders not having fixed hand wheels shall have key handles or non-adjustable wrenches on valve stems while these cylinders are in service. That's so you can get the thing shut off if there's a problem. Always make sure if you use the type that has the T-handle or the wrench to open it, that thing is on there all the time when you're using it, so that if it needs to be shut off, it can. Cylinder valves shall be closed before cylinders are moved. Cylinder valves shall be closed when work is finished. Cylinders shall be kept far enough away from the actual welding or cutting operation that sparks, so that sparks and hot slag do not come in contact with them. Cylinders shall be placed where they might become, or shall not be placed where they might become part of an electric circuit. Cylinders shall never be used as rollers. The numbers and markings stamped on the cylinders should never be tampered with. No person other than the gas supplier should attempt to mix gases or fill cylinders. No one shall tamper with the safety devices on the cylinders or valves. A hammer or wrench shall not be used to open the cylinder valve. If the valve can't be opened, contact the supplier. Cylinder valves shall not be tampered with, nor should any attempt be made to repair them. That's the job of the gas supplier, once again, to take care of that stuff. Fuel gas cylinders shall be placed with valve end up whenever they are in use. Before connecting a regulator to a cylinder valve, the valve has to be cracked open slightly. That blows all the particles of dust and dirt or anything that may be in the seat out. Okay. Before a regulator is removed from a cylinder valve, the cylinder valve shall be closed and the gas released from the regulator. Nothing that may damage the safety device or interfere with the quick closing of the valve shall be placed on top of the acetylene cylinder. If cylinder valves or fittings are found to have leaks that cannot be stopped by closing the valve or fitting, the cylinder has to be plainly tagged, placed outdoors away from sources of ignition, and then contact the supplier. Fuel gas shall never be used from cylinders through torches or other devices equipped with shutoff valves without reducing the pressure. Okay, always make sure you have a regulator on everything before you try running gas out to a torch. The cylinder valve shall always be opened slowly. An acetylene cylinder valve shall not be opened more than 1 to 1.5 turns of the spindle. That allows you to close it quickly in case there's an emergency. Where it is necessary to supply a number of workstations and conserve space, both oxygen and fuel gas may be supplied through a manifold system, and that's what we have out back here, where you have several bottles all tied in on a manifold, and they go out to the different stations. A acetylene manifold must be equipped with a flash arrestor to prevent flashback through the manifold into the cylinder. Okay? There is the full cylinder pressure of 2,000 psi in the oxygen manifold pipes. The manifold regulator reduces the pressure to 50 to 75 psi in the line that goes to the various stations. Both types of manifolds have pressure regulators for the purpose of reducing and controlling pressure of the gas to the workstation. Manifold piping systems for acetylene or acetylene compounds should be steel or wrought iron. Copper can be used for oxygen piping systems. Acetylene generators, that's another way of feeding acetylene into a shop. They have what they call an acetylene generator, where you just basically dump the calcium carbide and then the water is dripped in on top of the carbide, and that makes the acetylene, and then it's piped out throughout the shop too. We don't have one. We actually thought about getting one when we first put the shop together, but we've just been using the bottles on a manifold. All right, okay, as far as equipment for oxyacetylene welding, okay, some of the stuff that's required: oxygen regulators, acetylene regulator, oxygen welding hose, acetylene hose, hose couplings, single-purpose cutting torch or welding torch, cylinders and cart for portability, flash arrestor and check valves, flint lighter, striker, spark lighter, whichever you want to call it, to ignite the torch. And the approved protective equipment, personal protective equipment, of course, is necessary, but also things like backflow protectors, stuff like that prevent passage of flashback back into fuel gas supply systems, back into the hoses, back into the mixing chamber, stuff like that. We have all those on our torches out here. Okay, let's talk a little bit about regulators. The pressure at which oxygen and acetylene is compressed into cylinders is much too high for direct use in welding and cutting. Some means must be provided to reduce the high internal cylinder pressure, okay? You're talking about 2200 psi in the cylinder, so you have to get that down to a workable pressure, okay? And there's a couple of different kinds of regulators. One of them is called a two-stage regulator, which drops the pressure in 2 steps down to a working line pressure. And then there's a single-stage regulator, which drops it down in 1 step. And then you also have a station regulator, which is the small regulator at your welding or cutting station that will drop it down to a usable working pressure. Okay, let's see. Regulators reduce high cylinder pressure that is used for welding, and they can maintain that pressure without variation during the welding operation. Okay, two pressure gauges are mounted on the body of the regulator. One shows the pressure in the cylinder, the other shows the pressure out into the line. And that's the pressure that's being distributed out to the torch. Okay, the working pressure is adjusted by means of a hand screw, okay, the pressure regulating screw that's on the front of the regulator, and we'll go into all of this when we go in the shop and start working with this equipment. Okay, you always want to make sure before you turn on the gas to a station or to any kind of a regulator that screw is backed off and released and turning freely. Okay. Inspect all the nuts and the connections before you use them, and make sure that there are no faulty seats or anything like that. You can use a soapy water solution leak detector to check and make sure that there are no leaks. Okay. Before you open the valve of a cylinder to which a regulator has been attached, be sure that the pressure adjusting screw has been completely released or backed out. You don't have to back it out till it falls out, but make sure it's turning freely backwards. Never attempt to connect an acetylene regulator to a cylinder containing oxygen or vice versa. Okay, don't mix them up. Don't force connections. If it doesn't fit, it's probably not the right one. Use regulators only for the gas and pressures that they were intended. Have regulators repaired only by skilled people who have been properly trained to do so. Okay. Let's see, regulators are designed as single-stage and two-stage regulators. The operation of a single-stage regulator has just been explained. The two-stage regulator, the pressure reduction is accomplished in 2 stages. In the first stage, the spring tension has been set so that the pressure in the high-pressure chamber is a fixed amount. Okay, so you can set it for, say, 150 psi. Then it passes into a second reducing chamber that has a screw adjustment similar to a single-stage regulator, and you can adjust your pressure down to wherever you want it with that screw. For the most part, single-stage regulators are used with manifold systems, okay, which is what we have here. In these systems, the 2200 psi pressure is reduced at the manifold before it enters the piping system through a heavy-duty regulator on the manifold, and those are some big, heavy regulators out there on that manifold system. Then it's directed out into smaller stage or station regulators in our booths, where it can be reduced down to a working pressure. Acetylene regulators are required at each station. These regulators are smaller than cylinder regulators because they are not subjected to the high pressure that's coming directly off of the bottles. All right, welding torches. The welding torch is an apparatus for mixing oxygen and acetylene in the proportions necessary to carry on the welding operation. It also provides a handle so the welder can hold and direct the flame while welding. Okay, the handle has 2 inlet gas connections, one for oxygen, one for acetylene. Each inlet has a valve that controls the volume of oxygen or acetylene passing through. All right, tips on the torch. Oxyacetylene welding requires a variety of flame sizes. For this reason, a series of interchangeable heads or tips of different sizes and types are available. The size of the tip is governed by the diameter of the opening in the end of it. The tip size is marked on the side of the tip. The most common system consists of numbers that range from 000 to 15, and that's probably Victor's numbering system, I'm sure it is. The smaller the number, the lower the number, the smaller the tip, the less heat that's generated. The larger number, the larger the tip, the more heat that's generated. It's just a matter of the orifice in the tip being bigger or smaller. The larger the orifice is, the more gas passes through, the more heat. Okay, most welding tips are made of pure drawn copper because of the ability of this material to dissipate heat rapidly. Since copper is soft and tips are subject to considerable wear, both the tip and the threaded ends tips must be handled carefully. Okay? Do not remove the tip with pliers. Don't tighten with pliers. Just make them hand tight. Take them off with your hands. Okay? Never insert or remove a tip while the tip tube is hot. Okay? Allow it to cool before you grab it and start taking it off. Keep the orifice at the end of the tip clean at all times. Just use tip cleaners of the right size to make sure the thing stays clean. Do not use the tip as a hammer. Protect the seat of the tip on the back. If the tip is nicked or damaged, okay, it will leak at the joint where it's threaded to the torch. Okay, let's talk about hoses. The hose used for welding and cutting is especially manufactured for that purpose. It must be strong enough to resist internal wear, flexible enough so that it does not interfere with the welder's movement, and able to withstand a great deal of abrasive wear on the job. The things really get beaten and battered, so always make sure you check them constantly for cuts or burns or gouges or holes. Okay. The oxygen hose is green, and the word oxygen is sometimes molded onto the hose. The acetylene hose is red, and the word acetylene is sometimes molded onto the hose. Okay, don't always necessarily look for the words because you don't see it very often, but once in a while they're on there. But just remember, green for oxygen, red for acetylene. A black hose is used for inert gas and air. Okay, inert gas like argon or CO2 or something like that. Only hose connections made for the purpose should be used for connecting the hose to the regulator and the welding and cutting torch. A standard hose connection consists of a nipple that is inserted into the end of the hose and a nut that attaches the nipple to the torch or regulator so that there is no danger of attaching the wrong hose to the wrong regulator or torch connection. The oxygen coupling has a right-handed thread, the acetylene coupling has a left-handed thread, and the acetylene coupling also has a groove cut across the flats of the nuts to always identify it as a fuel gas nut. Okay, care of the hoses. Always use the hose to carry only one kind of gas. Don't switch them around and carry different kinds of gas with one hose. Test the hose for leaks frequently. Immerse it in normal working pressure underwater. Okay, check it, make sure it doesn't have any leaks. Clamp all of the hose connections or fasten them securely so that they will withstand a pressure of at least 300 psi without leakage. Hoses showing leaks, burns, worn places, and other surface defects are unfit for service and must be repaired or replaced. Do not attempt to repair a hose with tape. Tape has a tendency to break. Handle the hose carefully when welding. Avoid dragging it on the greasy floor. The hose should not be allowed to come in contact with flame or hot metal. They'll burn and melt through, and watch sharp edges too. Don't drag them across sharp edges. At the end of the day, or at the end of the job, roll up the hoses and hang where it will be out of the way. Let's see, spring-loaded hose reels are available. When lighting a torch, always use a spark lighter, striker, whatever you want to call it. Just make sure it's the friction kind with the flint. Keeps your hand away from the flame. Never use matches or cigarette lighters. And don't even carry cigarette lighters and matches in your pockets and stuff if you're doing this type of welding, any type of welding for that matter. Because any kind of sparks or anything that fall down in there could ignite them and really cause some problems. Okay, the filler rods. All different kinds of filler rods for oxyacetylene welding. Okay, mostly what we use is an ER70S-2. I see it referred to here in the book. It's probably the most common type, copper-coated, mild steel. Works well for both TIG and oxyacetylene work, so that's what we tend to use the most. Okay, a flux is a cleaning agent used to dissolve oxides, release trapped gases and slag, and cleanse the metal surfaces for welding, soldering, and brazing. Okay, most oxyacetylene processes, you probably don't have to use this until you get into brazing or welding some of the alloy type metals. Other gas welding processes, oxyhydrogen welding. Okay, oxyhydrogen flame is produced by burning 2 volumes of hydrogen with 1 volume of oxygen. The result is a flame with a temperature of approximately 4,100 degrees. Okay, that's nowhere near what an oxyacetylene flame is. Because of the relatively low flame temperature, this process is used principally in the welding of metals having low melting points such as aluminum, magnesium, and lead. It is also used to a limited extent the welding of light gauge steel and brazing operations. Okay, not very common. Fuel gases. Standard oxyacetylene welding equipment can also be used with propane, butane, city gas, and natural gas. It is necessary to have special fuel gas regulators when you use those other gases, though. Supporting equipment for oxyacetylene welding. Okay, a welding table, of course, C-clamps, carpenter clamps, grinders, files, cutting torch head, carbon in the form of rods or plates or plastic, highly fire resistant, used to protect surfaces and holes. Okay, preheating equipment, power brush for cleaning scale, safety equipment, of course, welding and cutting goggles. Okay, welders must wear specially designed goggles, protect their eyes from infrared and ultraviolet rays. People don't realize that even an oxyacetylene flame puts off infrared and ultraviolet rays. So we recommend you use a shade 5 all the time. Okay, make sure that your eyes are always protected. Have your glasses on underneath the goggles and everything else if you have to. Carefully select your shade to make sure that you get the proper filtration of the rays. Like I said, we usually recommend a number 5 for that kind of stuff. Make sure your goggle frames are made of a tough heat-resistant material. Okay. Try to keep them fairly light so that they're comfortable, not too miserable to wear. Protective clothing, about the same with any of it. Try and wear gauntlet gloves. Best to wear high-top boots, leather, steel toes, if you can, and sleeves, leather sleeves, or some of the fire retardant cloth. A hat. Always gloves, and always glasses and goggles. Make sure that all that stuff is of a non-flammable material. Wool or cotton for your regular clothes, but cotton ignites more readily than wool does, but wool's a lot more uncomfortable and hot to wear, so just make sure it's cotton. Make sure you have no frayed ends on anything. Make sure everything is kept free from oil and grease. You know, we talked about this before, but you don't want any oil and grease coming in contact with the compressed gases. Okay, flash guard check valves. They prevent the reverse flow of mixed gases in the torch, hoses, or regulators. One valve is required for the acetylene hose and one for the oxygen hose. They may be attached to the torch or the regulators. We have them directly on the back of the torch, right before the hoses, between the torch and the hoses. It's just simply a check valve that keeps everything from backing back into the equipment if there's some kind of a flashback or something. Okay, that's about all that's in this chapter, so read it very carefully before you take the test, and good luck.